So we're going to start now with circular motion. If you remember back to when we started this class, we started with everything in a nice horizontal straight line, correct? Right? We talked about how fast it can travel. We talked about how it can change its speed, right? We talked about all those things that are related to its motion. We were all just in a nice straight line. Then we took that line and we turned it 90 degrees, correct? And again, we talked about how fast can it fall, what's its acceleration like, right? How can we describe its motion? So we learned first horizontal, then we learned vertical, and then we put the two together, correct? We put the two together and we got projectile motion where it gets shot horizontal, but then that vertical piece also comes into play, and we got that parabolic shape for its motion, right? But the nice thing is we had two-dimensional motion, but we could break it up into one dimension each. We had two one-dimensional pieces to look at, and that made our life pretty easy, or easier, okay? Then we looked at forces, and we looked at what actually causes that motion, right? What causes an object to speed up? What causes it to slow down? What's causing it to move? All right? So for a little while, we're going to get away from things in a straight line, and we're going to look at what happens when they move in circles. All right? The nice thing is, a lot of the things that we've learned already apply to it. Now it's just in a circle as opposed to a line or a parabola. Okay? So let's say we start with a truck, right? We've got a truck here, and he's traveling this way. Well, you see, I should say, we're looking down on it, all right? So we're like up on a helicopter looking down on this truck. And you look down on the truck and you're like, what is this truck doing? Because you see this truck going around and around and around and around in a circle. And you're like, what is this guy doing? Why is he driving just in a circle? Okay? And this circle has a radius, and we'll call it R. Okay? So he's going around, just traveling, circle, circle, circle. The first thing I want to look at is what is happening to his direction as he turns. What's happening to his speed? So if we look at his speed here, this is the front of the truck. At this moment, he's traveling that direction, right? Okay? Well, the blue is his speed, right? He's traveling in this direction. If I look at him at this moment up here, he seems to be traveling in that direction, right? The front of his truck is traveling in that direction. If we look at him at another instance during his crazy trip, we see that he's traveling in this direction. So everywhere he's going, do you notice that his direction is changing? Okay, so his direction's constantly changing as he goes around this circle. No matter where he goes, at every instant, here, then it's here, it's always turning. And the thing that I hope you notice about the relationship of his velocity, right, his speed, to the radius is that they're perpendicular. Do you notice that? That wherever his speed is, I don't want that color. Wherever he is, his speed is always perpendicular to the radius of the circle. Okay? So, no matter where you are on this circle, the speed with which you're traveling, the direction of it will always be perpendicular to the radius of the circle, no matter what happens. Okay? If we now look, all right, so we've got that. He's also driving at the same speed. So he's traveling 4 meters per second here, 4 meters per second here. He's got 4 meters per second there. Right? He's going the same constant speed, but his velocity is changing. Remember that speed is how fast you're going. Velocity is how fast you're going and in what direction. So in this case, how fast he's going is always the same, but the direction he's pointing in is always different. All right? So what I want to be able to do is, from this information, I want to be able to calculate how fast is he traveling. All right? How fast is he going around this circle in? We learned in the first unit that velocity is distance divided by time. Okay? But that distance we usually measured was from like one point to another. Okay? It's a little hard to do that when we're talking about a circle because it's not a straight line. What distance is he traveling? Well, if we look at the path that he's traveling, what would we call that? Michaela, are you going to? No? Chris, you got an idea? Yeah. The distance that he's traveling is the circumference of this circle. All right? Now, what would we, instead of calling it distance, how could we write the circumference of the circle? What? 2 pi r. 2 pi r squared is not an equation. Pi r squared is the area. 4/3 pi r cubed is the volume. Okay? So the distance that he travels is equal to the circumference of the circle. Right? That's where he goes. Now, if he's traveling this circumference at the same speed over and over and over and over again, does it make sense that he's going to make one circle in the same amount of time every single time? Right? It's going to take him the same amount of time every single time he goes around because he's traveling at the same speed. So instead of calling it t, lowercase t, we're going to call it capital T, and we're going to call it period. Okay? So when we talk about time, lowercase t, it's usually the time it takes to make a trip. Okay? When we talk about period, capital T, it's the time it takes to go around once. Okay? Because typically when we start to talk about circular motion, we start to talk about things in terms of going around once, because you're doing the same thing every single time. So why talk about 17 circles when one is the same thing? Okay? So he's going to travel the same circumference every time he goes around. It's going to take him the same amount of time every time he goes around. So we call that the period instead. Very quickly, this deals with, it comes into play in circular motion. It also comes into play when we start talking about waves and sound. If I have the period, it's equal to the inverse of this thing called the frequency. And the frequency is equal to the inverse of the period. The frequency is the number of times you go around in 1 second.
Wait, so what's the thing on top of that?
1 over the frequency. Okay. So the number of times you go around in 1 second is called your frequency. And it's the inverse of your period. Okay. So if you had a period of a half a second, that means your frequency would be 2 turns or 2 revolutions in 1 second. Okay. You may see a little bit of this when we talk about this. Frequency, you'll see more of it when we get to waves. Okay. So now we know how to find his speed. It's just the circumference of the circle divided by the time it takes for him to go around once. Okay. So, like we talked about, the speed that he goes around is the same every single time. He's traveling how fast he's going doesn't change. But his direction is changing. Okay? His direction does change. Look, so something's going to be causing that. What typically causes a change in direction? All right, force, good. So a force causes him to change his direction. All right, so we're going to look at, then, what direction is this force being applied? All right. I'm going to get rid of this, this guy right here just so he's out of the way. Don't want that. Where's my orange? That's my orange. All right, so let's think about, you see a friend running down the hallway and you want to catch him and stop him and talk to him, whatever. So you throw out your arm and you grab him. What happens to their motion? They kind of swing around, right? They kind of swing around like that, correct? Now, which way are you pulling them when you hold on to them? Into you, right? So they're swinging around in this kind of circle, curved path, and you're holding on to them, pulling them towards you. Okay? So the force is being directed towards you. Okay? The same thing is happening with this truck. All right? Only there's not someone like holding on to the truck, pulling it in, but there is a force that's causing him to change his direction. And it's directed, again, inward, right, towards the center. Okay? So at every instance, right, there is a force pushing the truck towards the center. Okay? So at every instance, there's a force that is, again, now perpendicular to the speed that is pushing him towards the center. Now, we've learned, we did a ton of stuff with Newton's laws, right? We learned that a force causes a change in motion, right? Causes something to speed up and slow down. In this instance, it's not causing a change in motion, but a change in speed. I'm sorry, not in speed, in direction. All right? So in this case, the force is not causing it to speed up or slow down. The force is causing him to go in that curved path. Okay? Does that make sense? Yep.
Wait, so is there always going to be a force? Like, is the force always going to be going towards the center, or is it just...
When we have circular motion, it is towards the center. Yep. In this case, that thing that is causing it to turn towards the center is friction. Okay, friction is pushing the truck towards the center of the motion. I'm sorry, to the center of the circle. That instance where you grabbed your friend, you are the force that's pulling the object, pulling your friend towards the center, right? There's this kind of weapon thing called the bolo, where you've got, it's like two rocks or two kind of balls or whatever, and they're connected by a rope, right? And you can swing them over your head and you can throw it. Right, and you can usually catch something, and it might swing around, like knock them in the head or whatever, and things like that. So when you swing it, right, the rope is causing that center-seeking force, that force that's pulling the rocks towards the middle. Does that make sense? Okay. So this force that's pushing things towards the middle is called a centripetal force. Okay, it's called a centripetal force. Centripetal means center-seeking. Right, so it means it's directed towards the center. Now here's the thing that's really messy. Not messy, but it kind of messes with your head a little bit. There's no such thing as a centripetal force.
Wait, what?
There's no such thing as a centripetal force. When we talk about friction, friction's an actual force. There's friction. We talk about weight. Weight, we can figure that out, right? We talk about the normal force. Oh, look, there's the normal force. Pretty simple. They're there. We know what they are. Centripetal force, there's nothing that is specifically a centripetal force. A centripetal force just characterizes a force that is directed towards the center. So, friction can be a centripetal force. Tension could be a centripetal force. Right? Some sort of applied force could be a centripetal force. Your weight could be a centripetal force. We're talking about like orbits and planets and satellites. Right? Your weight then is a centripetal force. All right? So anything that pulls an object towards the center of a circle is a centripetal force. Does that make sense? So there's no actual thing that we can say, all right, that's a centripetal force. It's just a way of characterizing anything that pulls an object towards the center of a circle. Okay? We can calculate that centripetal force. Before we get there, actually, let's go with our acceleration, just so we can see. What direction does acceleration always go in? Well, which way does it follow? Follows what? Yeah, it always follows the force. So if the force is going towards the center, the acceleration is also going towards the center. Okay? And again, that force and acceleration is what's causing the truck to always change its direction. It's not changing its speed, it's changing its direction. If I want to know what that centripetal acceleration is, again, that center-seeking acceleration, it's v squared over r. Right? It's the square of the speed divided by the radius. Okay. And your centripetal force then is mv squared over r. And we get that just by doing F equals ma and substituting a in right here. And we get mv squared over r. Okay. Does that make sense? Okay. This is centripetal acceleration, centripetal force.
Is the M just for mass?
M is mass. Yep. Okay. So the last thing we'll talk about. This truck's going around in a circle. Let's say that all of a sudden we cut out this force, right? This force is gone. What direction does the truck go?
Into like a straight line.
So I got rid of it. I'm going to cut the force right here, right? So let's say now friction is the force that's pushing the truck around in the circle. All of a sudden friction's gone. Like you hit the patch of ice. Right. He's going to go in the direction of this blue line in a straight line. Right? So, and he's going to go in a straight line forever and ever and ever and ever until something else acts on him. Right? Think of Newton's first law. He's not going to go out and curve like this. He's not going to curve around this circle. He's not going to go this way, whatever it may be. He's going to go in a straight line like that. Okay? Remember, if you need a curved line, you need another force to act on you. Okay? Make sense? Okay? It's a little bit different way of thinking about things, but it's all still related to what we've already worked on. Okay? Good?